Hi everyone, welcome back. My name is Anubhav and I am very excited to be back at YouTube after a gap of 1 year. The last video I uploaded on YouTube, an educational content I uploaded on YouTube was back in January 2025, and this is December 2025, so a break of 12 months here and there. Pretty much excited to be back. Today we are looking at covering Kubernetes because this is a topic which I have been exploring myself for past couple of weeks now. I always knew about Kubernetes. I at a higher level understood what it was supposed to do, the different terminologies associated with it, but never really got a chance to actually work into it or deep dive into it. So covering up this bit in holidays, so I thought, okay, what's a better way to learn things? And I mean, it's a good way to learn things and share the knowledge, right? So that's why I'm here with a Kubernetes tutorial. And so Kubernetes, if you look at it, there are many different things to cover in Kubernetes, or K8s as we abbreviate it, starting from pods, deployments, services, config maps and secrets, persistence, volume, stateful sets, Helm charts, etc. So it's a very vast subject. But in today's tutorial or in this video, we would be looking at something called pods, which is the smallest unit that you could find in Kubernetes. I think you can already see the slide over here. The sections are highlighted. I mean, the sections are there, which will be covering over the course of next 4 or 5 videos. But this specific video will cover things about pods, the basic unit in Kubernetes. This is the smallest unit available to us in Kubernetes. So I would not take much of a time in the theory and all that stuff. Rather, I would directly move on to practicals, show you guys some cool stuff, how to deploy, so I mean, how to use pods, what exactly are pods, use kubectl to apply the pods, do some certain bit on that and stuff like that. I mean, the actual hands-on rather than boring you with the the intrinsic theory. So what I will do is I will switch on to my iPad maybe and take you over there so that it's easier for us to understand what we are going to build, how we are going to like apply the pod and all that stuff. So yeah, let me take you to the iPad. I think we should be all good over here. Oh, asking for my touch ID. Yeah, unlocked now. uh, let's say allow, and I will pop up my good notes. So and let this be in a full screen mode so that everything looks good. I will start up a new notebook. Oh, and it says I have reached my notebook limit. That's interesting. Yeah, so I am back after the short glitch. Sorry for that. Somehow I just reached my good notes free quota limit, so I had to empty my trash and pop up a new notebook. But with that being sorted, let's focus on today's topic, which is going to be all about pods. So yeah, today's topic is going to be all about pods, and I will first walk you through the architecture. So I've built something, right? Like I have two microservices up and running on my local currently, right? Which I'll be using throughout the course of this entire series, to, let's say, first explain you pods, then deployments, then services, then maybe config maps, secrets, and then essentially help chart. So I have two services up and running on my local, which I'll be using to explain you all this stuff. So it's very important we first get an idea of what these microservices are, what it is doing, how they are connected to each other, and how we'll be essentially using them to understand the concepts of Kubernetes. So what we'll do is we will hold on pods for a bit, right? Right now what we are discussing is the uh, service architecture, the services which we will be using to learn about these things. Uh, so but uh, so yeah, let's not wait. I mean, I will pop up two boxes for you. So this is my microservice 1 and this is my microservice 2. Both of these are essentially Flask apps. So which means that these apps are written using Python, right? So it's Python in the back end, or you could say Flask as a, like Flask is the framework that's powering it. Microservice 1, I called it as a, or I have named it as credit check microservice. Microservice 2, I have named it as decision microservice. And apologies if my handwriting is bad and you're not able to understand a lot of things written over here. This is because I am actually using iPad and let's say GoodNotes for the first time. I'm not very comfortable in using that, so my hands are still like getting used to it. So if there's a glitch or you are seeing something odd, please bear with me. So yeah, we have these two microservices, the microservice 1, which is called credit check microservice, and the microservice 2, which is called the decision microservice. So what credit check microservice does is it takes in three parameters. One is your name, right? Another is your ID number, and third is your DOP as input, right? So this is the input request, or these are the parameters it expects in the input. And what it does is it will return you a credit score. So it will return you something like credit score, let's say 800, and the last refreshed date, let's say whatever the date is. So this is the request for it and this is the response for it. There is no specific logic or there is no actual credit check that's being done, so do not worry about that point. It's just a random.rand int thing that I am doing, like just checking if these fields are valid or not, as in these are not empty or not, these are empty or not, and then if these are not empty, then just doing a random.rand int which will return you the credit score and today's date as the last refresh date, right? So this is what credit check microservice does. The decision microservice, on the other hand, is actually a bigger microservice. It takes it input as your name, your ID number, your date of birth, the type of loan that you are looking for. So this is actually a loan application, like these two microservices are a part of a loan application. So type of loan that you are looking for, this could either be something like your car loan, personal loan, or home loan. The loan amount in number, it could be something like 5 lakh or something, and the loan tenure, right? So let's say 4 years, or for just 4 for example, right? So something like this. So this is what is the request for this specific microservice. So what will happen actually is, once we verify that all these things are correct, like user has sent all these things, right? Microservice 2 will internally call microservice 1, which is a credit check microservice, and get you the credit score, right? Now, depending upon your credit score, your type of loan, your loan amount, and loan tenure, in microservice 2, which you can treat it as a black box because we don't need to understand what's actually happening over here, certain rules have been configured which will say whether your loan has been approved or not. So result is loan approved or loan rejected, right? So this is what it happens. So these are the two major microservices we will be working with. I know the it does not look too great on the screen, but as long as I am able to pass the correct information to you, I am all happy. So we have two microservices. Microservice 1, which we call as the credit check microservice. It takes in three parameters, which is your name, your ID number, your date of birth in the request, and just doing a random dot int, it returns your credit score and the last refresh date, which is going to be today's date. Microservice 2 takes in a few more parameters, which is your name, your ID number, your date of birth, your type of loan, which has to be among these three, the loan amount, and the loan tenure, right? If all these parameters have been passed, it makes a call to credit check microservice, which is microservice 1, right? And as you can see, microservice 1 expects this information, and the same information is being passed from microservice 2. Credit check microservice returns your response, which is the credit score. We are most interested in this credit score, and based on the combination of credit score, the type of loan, the loan amount, and the loan tenure, microservice 2 returns you the result whether your loan is approved or your loan is rejected. So your entry point is going to be microservice 2, right? Like this is your actual loan application service. Like imagine you would have a front end for it as well, where you have a beautiful form with name, with fields like name, date of birth, ID, type of loan, and all, right? This is the backend system for it, right? Which you can treat it as a black box. But only thing that we are concerned about is that this will make a call to microservice 1, which is a great check microservice, to get you the score and then actually get you out the result. So this is what our entire architecture would look like. I hope I am able to make you understand the components of our microservice. Till here things should be fine. Yep. So now, after having a basic look at the architecture, I think we're all good to start with pods, right? So, first question first. What is a pod? I mean, in Kubernetes, which we also call as K8s, by the way. So if you see the term K8s, don't be confused. It's just a abbreviated form for Kubernetes. A pod is the smallest possible unit, right? So you know about Docker container, right? Like I assume because so Kubernetes is a container orchestration tool, right? So understand an orchestration tool by this way. Let's just suppose I have a um, an e-commerce website, right? Uh, I have an e-commerce website. Now this e-commerce website, I have deployed it using a like I have deployed it using a Docker container. Okay. So what I've done is I created a Docker image for it, right? I built a Docker image for it. Maybe I stored this image in the Docker registry or Docker hub, whatever you would like to call it, right? And I popped one EC2 instance for me and deployed this using the using Docker. I just deployed this service onto an EC2 server, right? uh, my assumption was, or my use case was, I wanted to be up and running in the bare minimum possible time, and this is the fastest approach for me. Things work, right? And I am now live, and let's just suppose this e-commerce store is about some Christmas presents, right? Some unique Christmas gifts. Okay. So somehow, and because this is Christmas time, what happened was this store become quite popular, right? So a Docker container would have a limit of the number of requests that it could handle, right? Like it's not supposed to be very powerful. I mean, it will have its limit depending upon what you have set. Let's just suppose that what happened was, because it became so popular, because the store became so popular, I understood that one Docker container is not able to handle the load. So what I will do, I will basically pop up one more Docker container, right? Let's say on the same EC2 server, I will pop up one more Docker container for the same thing, right? So now if I were to draw a bigger image, let's say this is my EC2 server. I have one Docker container over here for my e-commerce website, a Docker container over here for my e-commerce website, and let's have a load balancer in between, or something of that sort, right? Which will say, okay, which container to forward the traffic to, right? All good. Things look fine. Two is enough. But during as we come near to Christmas, right? The traffic on this started on increasing, right? And now two Docker containers are not enough. What I will do, I will pop up one more Docker container, right? Which is like I will pop up one more Docker container, which will just like now scale the traffic. So again, if this is the EC2 instance, so you have Docker container 1, ECW, e-commerce website 1, ECW2, ECW3, and ECW4. Let's say I have 4 right now, right? Like to handle the load. Things look all good. Now somehow a very famous celebrity tweet about my website, right? And so what will happen is that the traffic to my website will increase now even more. Now 4 Docker containers are not enough, so I will need to pop in a fifth one. So you see, right? Like you see this pattern every time we are we have to do something, we are just popping up Docker containers again and again, right? Like it's a very tedious task to do something. Now we can assume a scenario, right? There was a bug in my website and I have resolved this bug. Now, because I have resolved this bug, which essentially means that this requires an image update. So this would require an image update in the first container which is running, the second container which is running, the third container which is running, the fourth container which is running, right? I have only 4 right now, but as I mentioned, like my site is growing crazily. So what happens if like there are 10 different containers running for it, which essentially means that manually I would need to like update the image for all 10 of them, right? Which is going to be a hectic task. It might also happen that midnight one of my container crashes because the load has been very high, which essentially means that now I'm only left with let's say 3 containers, and I would have to manually bring this container up. So again, a tedious task for me. And you see where I'm leading to? This is what a container orchestration platform will do, and this is what Kubernetes essentially does, right? It abstracts out all these things for you, all these painful things for you, and does the orchestration. So on the very base of Kubernetes is actually going to be a Docker container, and with Docker container, you know that you have to have a Docker image and stuff like that, right? So essentially Kubernetes is just a container orchestration platform at its very basic. So with the help of the example that you understood, right, any of these tasks, the orchestration tasks that were going to be painful, Kubernetes would be taking care of them. So this is what it is. I will pop in a new page. Yeah, all good. So now let's be back to pods. So a pod is, as I mentioned, is the smallest deployable unit in Kubernetes, right? So you can assume it as an abstraction over Docker container, right? So it's Kubernetes, right? So it's all, the container is always going to be involved. So let's just understand it this way. You have an image. Over an image, you have a Docker container. And over a Docker container, you have a pod, right? So pod is just an abstraction over your Docker container, and it's the smallest unit that in Kubernetes that you can play around with or that you can actually use. So this is what a pod is. You can always refer to the official documentation. So if I take you to Kubernetes pods, right? So pods, the smallest deployable units of computing that you can create and manage in Kubernetes. This is what the official definition says. So yeah, this is what I told you. I will take you back to my iPad screen. So what we will be doing over here is we have these 2 microservices, right? Like I think microservice 1, we called it the credit check microservice. and microservice 2, we called it as the decision microservice, correct? So what we'll do is we will create the pods for them, right? The way you create a pod in Kubernetes is these. So everything in Kubernetes is just a YAML file, right? So we will pop in a new YAML file. We will see what are the different things in that definition that we give in that YAML file. The key value pairs, what does it mean? Stuff like that. So we will be writing the this for both of them. And the way we'll be doing is right now I have only these microservice up and running, right? I will be first creating the Docker image for it, for both of them basically. Then I will be starting my Minikube cluster. So if you're not familiar, I am doing the entire Kubernetes setup in my local, which is why I'm using Minikube. So Minikube is like same worker master node combination. So does not consume a lot of resource. So it will just give me a node to deploy all my services to, right? And then I will be writing pod definition for both of them, and then apply the pod definition and show you what it means. I hope this does make sense, right? Like, I hope things make sense still over here. My laptop screen, this is the microservices that we were talking about, because for these microservices we would need to write the Docker files first, build the image, and then use the image in the pod definition, create the pod definition, apply the pods, and then show you stuff, right? So yeah, I mean, this is what it is. So as you can see, like I have these two microservices. As I told you, the credit check microservice, which is a Python app, a Python based Flask app basically, which has one endpoint, which is API slash v1 slash credit check. And as I told you, it's just doing a random.rand int and giving you a random credit score, right? And this is my microservice 1. My microservice 2, which is also going to be my entry point, is the decision microservice. And as you can see, it has this endpoint called API slash v1 slash decision. What it does is, after checking a bit of things, it actually calls the microservice 1, which is a credit check microservice. I'm using environment variables to pass in the URL over here. This is where the URL is constructed, and based on, like, you can treat that as a black box based on certain things. It just tells if the loan is approved or not, or if it is not approved, right? So if I hit this API from my postman, which is localhost 2212, because this is where I'm running my decision microservice on, with the endpoint as API slash v1 slash decision, I click on send, you will get that the loan is conditionally approved. To see if the request has been received by credit check microservice or not, you can always go back to this microservice, check its log. So as you can see, the request was received, right? Like, this is what I sent, and the request was received on 21st of December 2025 with the time as 2014, which is 8:14, which seems all good to me, right? I click on it once more, still approved. Click on once more, loan is not approved. So yeah, this is working fine. So this is what we would be writing the all the necessary things for. So first, let's go to our first microservice, which is the credit check service, right? And let's write a Docker file for it. Writing a Docker file is going to be super easy, nothing complicated as such. So what we'll do is, from Python 3.12, which one should I pick? From Python 3.12, Docker file for this credit check microservice. So what I'll do is, I've created the Docker file already, as you can see. So from Python 3.12 dash slim is what I am using as the base image for this. I will change my work directory to /app. Now it's actually easier to write a Docker file, right? Like you can just assume things to be a clean slate and what you would do when you would actually need, like you have a fresh system. So for any service, what you actually require is a requirements.txt file, right? So I will actually first write a requirements.txt file. And in the requirements.txt file, I will see what my dependencies are first. So I think my only external dependency over here is Flask. So I will just write Flask, right? So now going back to my Docker file, what I will do, so I've already said that I want to install Python 3.12 slim image. I need to change my directory to work directory. Then I will do copy dot, which essentially means that I don't know, how do we write, like is it copy dot or copy dot, I just forgot. I think this would be like this, which tells that copy everything from source directory to the destination directory. So copy every file from over here to the slash app directory basically. Then what we'll do is we will run the command, and when you copy all these files, which is your app file, app.py, a docker file, and requirements.txt gets copied, then I will run the command run python 3 -r requirements.txt. All right, so what will happen is once you have like copied everything, the requirements.txt file is now available to you in your Docker container. So now run the command python 3 -r requirements.txt, which will install the required library for you. Then we also need to expose the correct port. So expose, and I think we are exposing port 2112. So going back to Dockerfile, expose 2112, and I will just check the syntax if it's expose port or expose. So yeah, it's just expose the syntax, so all good. And then we would have the command something like python 3 followed by app.py, right? This is how we run the file, right? So I will just walk you through what's happening in the Docker file. So what we're doing is we are first saying that imagine Docker as a system with a clean slate. It has nothing, right? So first you would need to install Python. Installing Python is very easy. Like you can just write from Python 3.12, that's slim. Then change the work directory to slash app, copy everything from source to directory. So this is what it does, right? Not a good way to do it. Like ideally first you should be copying the requirements.txt, right, and then copying the rest of the files, but I think that's okay. Like we are still running things, so it should be fine. Then run python 3 -r requirements.txt, which tells that okay, install all the requirements for me in my Docker container. After you have installed Python, expose the given port, which is the port on which your app is running, and then saying what's the command that you want to trigger to start up this app. So if you're starting a Flask app, use python 3 app.py, or python 3, what's the name of the file that you want to trigger, which in this case is python 3 app.py. So yeah, we have it in a Docker file. The next step is to build a Docker image for it. So we'll first check if my Docker desktop is up and running or not. I think my Docker desktop is all good, up and running. So I will just write docker build -t. I will name this image as credit check v1 followed by a dot. So yeah, this should build things. Let's see. Should be real quick, maybe 15 seconds more, I believe. It says it failed because requirements .txt. Did I make any error? Failed to solve the process, did not complete successfully. Failed to solve the process, python 3 -r requirements.txt did not complete successfully. And if I see requirements.txt, it just contains the file. Copy file name. I will just make sure there is nothing over here. I will see if I have not made an error. uh, Oh, yeah, it should be pip. It should not be python 3 dash r requirements.txt, right? You do pip install, right? And not python 3 install. So, yeah, it was my fault. So, pip 3 install dash r requirements.txt should be good now. Yeah, I still need to refer things somehow even at this stage, because keep on forgetting things if you are not like very uh, hands-on with this stuff, or like your muscle memory becomes a bit weak. And yeah, as you can see, like all good. And if I go back to my Docker desktop now, fully it should open over here, images, I security check v1 is all good now. Awesome. Shall we do the same for our decision service as well? And I would say let's do it. For my decision service, uh, the outside things that we are using are Flask and request. So I would first create the requirements.txt file for this. Requirements.txt, Flask, and requests. Right now, let's create the Docker file for this. From Python 3.12-slim work dir slash app copy dot run pip3 install dash r requirements.txt expose port. In this case, the port is 2212 cmd python 3 app.py. Yep, and let me build Docker file for this, which I will do using docker build -t decision service v1 dot. Yeah, should be done within 15 seconds is what my understanding is. Yeah, quicker than that. And if I go back to my Docker desktop, yes, you can see that both of these are now up and running. So fantastic job till now if you have stayed over here. Though we have not achieved much, but yes, I've given you a walkthrough of the services, microservice 1, microservice 2. We have written the Docker file for that, build the Docker image, and now like what we'll be doing is building the pods out of it. But if you have stayed till over here, kudos, like things are now finally going to become much more interesting. Yeah, now so both the images are available, and um, both the images are available now. At the time we can actually start writing the pod definition. So as I told you, right, like what we are using currently is known as minikube. So what minikube will do is it will spin up a single node or a single node cluster for me. What I mean by a single node is that both the master node and the worker node are going to the same. So Kubernetes, which I know I've not explained you this part, the structure of Kubernetes, the architecture of Kubernetes, but for those who are aware that Kubernetes actually follows the architecture of master node and worker nodes, with each having its dedicated task, right? And worker nodes are the one who are actually responsible for spinning up the pods and all. But in case of Minikube, what will happen is it will only spin up a single node, and that single node is going to be the both worker node and the master node for us. And once that's spinned up, like we can use the kubectl commands to interact with the cluster, right? Do stuff as we want, and then get along with it. So yeah, this is what it is. What I will do is I will directly write something called minikube start, which will spin up the cluster for me. So as you can see, it tells me that minikube is on Darwin, and it is restarting existing containers and pulling up some base images and something of that sort. So yeah, I think the cluster is all up and running now. What I can do is I can use the command kubectl get nodes to see if my cluster is up and running. So yeah, the minikube cluster is now up and running. It says the age is 33 hours. Kubectl get pods to see all the running pods. Maybe I will actually delete these pods for you so that there is no confusion. So kubectl delete pods. I mean, these are from my personal projects. You don't need to be worried about that. When you start when you install Minikube and you use kubectl, you would be doing it for the first time. So, uh, kubectl get pods. Okay, kubectl uh, delete pods. Delete pod this, and kubectl delete pod clear kubectl get services, maybe delete this, kubectl delete service followed by this, and kubectl get deployments. If there is any deployment, yep, there is a deployment. So kubectl delete deployment. Yep, I think so. Now we should have a clean slate, and I will just recheck if that's the case. Kubectl get pods should return you no pods. No pods, yes. Kubectl get services should return you no services. It's only the Kubernetes service, which is fine. Kubectl get deployments, and there should be no deployments. So yeah, we have a clean slate now. Our minikube server is up and running. We have one node cluster containing both the master node and the parent node, right? So what now we'll be doing is we'll be writing the pod definition for my microservice one, which is my credit check microservice. So what you can always do is you can always go to the pods definition in Kubernetes. Like you can always search for pods Kubernetes, go to the first link, and that will pop up the YAML file for you on how you'd write this, right? I can actually try writing it using the Vim editor itself. Seems to be okay. So I will first ls, and I will go to cd credit check service. What I'll do is I will write vi credit check deployment dot YAML, right? And yeah, I've opened up the Vim editor for me. So what I need to do is I need to write something like API version, which I think is v1. The kind of service that I am building is pod. Then you have something called metadata. In metadata you have name. Oh, interesting. The Vim is not actually like doing an indentation properly, so maybe I will quit and I will use my Sublime text, because that would be a better option then. So file, open, go to of Kubernetes credit check service and credit check deployment.yaml. Yep. So something like API version, which is v1, kind as pod, metadata as name, like metadata with the name as credit check deployment, and labels as operation is like labels is something that you can give on your own. Does not matter, like it's just used for selecting stuff. So actually the most common is called the most common key value pair is app followed by the name. So I will just write credit check service, credit check service deploy. I don't want to use the word service because service is also a component in Kubernetes. So microservice deployment, right? And then you would have something called spec. In spec, you would have something called containers, right? I mean, I remember the syntax because of my muscle memory, but you can always refer it from over here. Like that should be all good. So yeah, let me go back. Containers, it's obviously going to be a list. So the first is going to be name, and in name I'm going to give it as credit check microservice image. In image it is going to be credit, we can always refer it from our Docker desktop, it's called credit check v1. So go back over here, credit check v1, all good. And I think maybe we need to put this in double quotes so that yeah. And ports again, I think it's a container port, and in container port I think if I just check the syntax, it, yeah, whatever container port you're exposing your microservice to, so I think we are exposing it at 2012, so it should be all good. So this is what your file looks like, the pod definition file looks like. Obviously, like always, use the official documentation to refer to the syntax, but the main thing that we want to note over here is the name of the deployment that we are going to have, which I have called as credit check deployment. The app label is called credit check microservice deployment, and this is where I specify the image things, right? So yeah, pretty much, like, I mean, nothing much to explain. You all are intelligent guys, you understand seeing the definition, what's happening. So I will just save it, and after saving, what I will do is I will do a kubectl apply -f credit check deployment.yaml. Hopefully everything should go through, and it says that a pod has been created. Let's see what happens. So kubectl get pods, and as you can see, I am getting an error image pull. And why is this so? And yeah, this is so because I know why it's happening. So as per you, it should be that, okay, this is existing in my Docker desktop, so it should not be an image pull error because I have given the correct name. But this is because Minikube could not access things in my Docker desktop. So we need to have a way, and there is a way that we need to transfer the Docker image from Docker desktop to Minikube. And I will have to search for it because unfortunately I've forgotten. So what I will do is I will pause the video, search for it, get back, and then recontinue from over here. Bit of search and all, I have got the workaround. So the workaround for this is we just need to write minikube image load followed by the image name, which in my case is credit check v1, I believe. Yep, it's called credit check v1. So if I do something like this, credit check v1, the image should be loaded onto Minikube. Let's just see, fingers crossed, hopefully it should work. And yep, and if I now see kubectl get pods, it says that it cannot be ready because there's an image pull back off. And yeah, and as you can see, because there was an image pull back off, it was not ready. But as soon as I did this thing, right, it took a bit of time, but now my container is now up and running. Maybe you can see a few more things over here. To do so, you can do kubectl describe pod followed by the pod name, which is like this. And yeah, over here you can see much more stuff, like it's there in the default namespace, the node on which it is running, the start time, which is today, it's time 21st of December 8:56 p.m., the labels for it, the status, the IP, the pod IP, which is going to be ephemeral, right, and the image ID, the restart count, all those stuff. And yeah, this is where you see and this is where you see all the entire event. So as you can see, there was this back off, right, and then like suddenly, because we did a minikube load of the image, then things started working. So in this way your pod is now up and running, right, and maybe you can do the same stuff for the other service, right. There are a lot of things to learn in pod, we'll come to that, don't worry. But yeah, I mean, let's do the same stuff for the other microservice as well. So we will cd dot dot, we'll do a ls, we'll do decision service, cd into that, and we will do a vi decision service pod.yaml. Right, close it from over here, go back to my Sublime text and open it from there. And this is decision service pod.yaml. Yep. So by now your muscle memory should have been developed about writing pods. So API version v1 kind is pod, followed by metadata is going to be your name, in which case I am going to name it as decision micro service, decision service pod, and labels as app decision service pod. Okay, and then you have the spec, inside spec you have containers, inside containers you have the name, which is decision service image, followed by the image name, which is decision service v1, followed by ports, where you have to give the container ports, and yeah, this should be container port, where it should be, I think, 20, this should be 2212, right. This is how it is, I think, looks all good. But before that, we need to do the same thing first, load the image into minikube. So minikube image load decision service v1, give it 15 seconds to actually load this. Should be all good now. And once this is good, what we will do is we will do a yeah, so we will do kubectl apply -f decision service pod.yaml. It says cannot be identified as unknown field. So there is a type over here, there should be spec, and let me see if it's spec or specs. It's just spec, so it should be all good now. I think I've saved it just to cross confirm. Yep, this is saved. Yep, now the pod is created, and if I see kubectl get pods, yeah, both the pods are now up and running, right? So I can again describe this, and this time we did not get the image pullback of error because I've already preloaded this thing, right? So kubectl describe pod followed by decision service pod. Yeah, and all good now. So both of them are up and running, right? But a question should come that we aren't doing a health check kind of stuff over here, right? Like there should be a health check kind of stuff which should happen. while when we are seeing that the pod is up and running, right? So that's not happening. Is there a way to configure this? And yes, there is a way to configure this. We call that as liveness and readiness pro. It's a very fundamental thing. We will discuss that in a bit basically, but yeah, what you're thinking is on the correct direction, and we shall be able to handle that real soon. So yeah, I think this is it with pods. But before closing, just a quick note that pods are ephemeral, so they are supposed to die down. Their IP is supposed to change and stuff like that. So we generally do not work with pods in Kubernetes. Rather, what we work is something called deployments, right? So next section we would actually cover more about deployments, so that things would be easier for you. But yeah, pod, it's just to get your hands dirty with pods. It's essential because those are the basic building blocks of it, and it's a quick win for us, right? So I hope you enjoyed the tutorial. If there is any feedback, let me know in the comment section. More than happy to address them. Thank you for your time. Thank you for your patience. Have a great and lovely day ahead. Goodbye.